My name is Tobias Sorn. I'm part of the UI5 core development team. And today I'm going to show you how you can actually leverage the HTTP2 protocol. So HTTP2 has a lot to offer, and I will show you how UI5 can benefit from it. Typically, the focus is on the front end, but now we're going to look at the back end as well and see how we can actually optimize this using HTTP2. So when looking into the future, we also need to have a look at the past. So in 1991, a great year by the way, the HTTP protocol was introduced by Tim Berners-Lee. He had simplicity in mind, and it was called the one-line protocol. That because in the beginning it consisted of a single GET request with the resource path, and the response was hypertext. It's an ASCII protocol running over TCP/IP. It was designed to transfer HTML, and the connection was closed after every request. In 1996, it evolved, also another great year, by the way, and there was a need for more metadata. So instead of just transferring hypertext, there was also the need to transfer different content as well. With that came the request and the response headers, as well as a status code. But still, the connection was closed after every request. In 1997, actually, the HTTP 1.1 got introduced. It got improved, and which is now the de facto internet standard in 1999. And this time, the focus was on the connection. So, wait, just need to have my mouse. Sorry. So there was a massive use of the server side. So keep alive and caching was used, and different content could be served using the HTTP 1.1 protocol. And also there could be many different responses being served. And actually 16 years later, in 2015, HTTP2 got introduced. I will need to say it's still on the way, so we are still looking into this future. And with that, with HTTP2, there are quite some benefits. So it was designed to decrease the end-user perceived latency. So it was trying to solve the performance issues, or actually it focuses on performance. It addresses the head-of-line blocking issue, which is that typically in a browser there are 6 parallel requests, each having a connection, and the 7th is actually blocked. And this led to what you all know, that files are concatenated, so there are big source files being created, lots of preloads, lots of bundlings, sprites. There's the concept of domain sharding, which means that these 6 parallel requests are per domain. So you actually try to split your resources on different domains to circumvent this problem. And HTTP2 addresses this by not using multiple connections, but one single connection, which can handle parallel requests. And of course, most important, we already heard in the keynote, it's good to be backward compatible. So the semantics of HTTP 1.1 are retained. So you don't need to change anything regarding request and response. The name HTTP2 is actually, it's called like this because it's a major change in the protocol. So it changed essentially. And the biggest change in this protocol is actually the binary framing layer. So instead, in HTTP 1.1, you had actually, for example, for this post request, it's one request. It contained the header and the data all in one, which led to quite some problems. So the typical problems in IT, encoding, special characters, you cannot properly separate content from header. And this is changed with HTTP 2, so you have a separate headers frame and you have a data frame. And these are transported via streams. So you can have one connection with multiple streams. Okay, and this leads to what is called multiplexing. So it's one HTTP 2 connection which has 3 parallel streams inside. They are non-blocking, which is really the important thing. And you really make the most out of the underlying TCP connection. Because if you think about TCP, it's optimized for long-lived bulk data transfers. Another cool feature is stream priority, where streams can be assigned a certain priority. The streams can have also dependencies among each other. And this way, the server side can actually use the streams wisely. So you can reserve then certain CPU or memory for high priority streams. So the server side can focus on the resources with the highest priority. Another feature from HTTP 2 is HTTP header compression. When you usually think about a header, it sounds not that big, but it's 500 to 800 bytes of overhead per transfer. And if you have cookies, it's even in kilobytes. So what HTTP 2 does, the client and the server side keep track of the headers. And this way you are able to identify deltas and only transport the deltas. So with additional compression performed, the HTTP 2 headers are way smaller than the HTTP 1.1 headers. You see here, for example, so from request 1 to request 2, the delta is just the path, which is, instead of /resource, is /new resource. And I think it's obvious that it's then way smaller. Actually, the concept which this presentation is based on is the server-side push mechanism. So what HTTP introduced is that using the connection, the server side can push resources to the client, even though the client doesn't request these resources. And these are called push promise frames. So for example, in the example, in this picture, the client requests page.1.html, and the server not only delivers this file, this page1.html, it's also delivering in stream 2 and 4 the script.js and the style CSS with the push promise mechanism. And all this actually brought me to the idea of implementing actually an intelligent HTTP 2 server. So the focus is, of course, performance. As we all know, faster is always better. Wanted to keep up with state-of-the-art technology. And I wanted to actually do a request analysis. So I wanted to proactively push resources to the client. So some in-depth. So this is basically the design or the architecture. And so bubble 1 and 2 you already know. So this is the typically you request something from the server and the server responds. So nothing new there. But in step 3, I asynchronously store every request in a database. And with that, I gather all from the history of all the requests, I get a subsequent requests, find out the best results or the best requests, and then push these to the client while it doesn't know that it actually needs it. So using the push frame mechanism. And this way, although the client just requests one resource, the server side pushes more than just this one resource because it knows what typically comes next. Okay, and now it's some demo time. So wait, I'll just need to start up. So I hope everybody can read this. So I'm actually starting my server, and I'm serving the OpenUI5 sample app. And with actually a clean analyze DB, I say first, okay, I don't want to push. In order to simulate a bigger app, wait, I clear everything. So this is the, wait. Okay, so now you see on the right-hand side that there are tons of requests being fired. It's everything, the sources are not optimized in order to simulate a bigger application or a application with more requests. And you actually see, wait, I have the magnifier. It's finishing in 6.64 seconds. It has tons of requests, tons of megabytes of not optimized source code being transferred. So wait, what I'm now doing, I'm stopping the server again, and this time I'm using the push mechanism and also with analysis. Get everything right. Okay, clear everything. I do so the caches are disabled. I do a Control F5. So now you see the same as before, because the server typically at first start it doesn't know, okay, it's not that intelligent, so it's just requesting everything. But what happens asynchronously, it stores everything inside a database, so it kind of builds this analysis for us, which means the second time I'm requesting everything, so cache is still clean. Wait, Control F5. You see also a bit of difference. Okay, and there's quite some pushing going on. So for now, the server, so I created a very basic, intelligent mechanism, so it actually gathers the five possible best subsequent requests, which are typically in the history within 1 second being fired. And therefore it knows, okay, for one resource I have, for example, 5 subsequent requests which are typically performed and then are proactively pushed to the client. And what you already see, I guess, if you hopefully remember the first number, because I don't, but it's quite some, it's now only 4.73 seconds, which is actually quite significant in some FLP scenario or some bigger scenario or with bigger apps, which you can imagine. Exactly, and the server gets more intelligent over time, actually, because it recognizes all of the subsequent requests and then can therefore serve resources faster and proactively push these resources. You also see these push requests in the waterfall diagram, and it's reading the push and receiving the push of several resources. The database which I used was actually pretty simple, so I used a JSON database. It's in memory, but it also asynchronously saves its state from time to time. And so I save actually the timestamp and the URL with every request, and then therefore I calculate what is typically best for the server. So the resources in the analysis are encoded, and for example, for this Belize library CSS, you see, okay, the subsequent requests are actually the manifest, some additional library CSS, some style CSS, and some properties files. Okay, so far so good. Let me just quickly get back to this slide. Exactly, so this was actually a pretty simple demo, but when you think of the future, you can actually also imagine some kind of OData push service where data can proactively pushed to the client, which is actually quite handy. Another cool thing, which was not yet leveraged, but would be the stream priority. You saw in the keynote it was about the modular core and the core modules, and giving these modules a higher priority would actually make the server spend its resources on these prioritized in order to serve this quicker and to maybe even improve this hero content, which is served faster. Of course, the biggest point, improving this intelligence, so this basic POC, which I did, could be actually pretty much enriched. So there could be different metrics, there could be different paths, different clicks which are performed, which trigger requests, and all this could be forecasted and then proactively pushed to the client. And of course, if you think about pagination, so some big table which is typically only showing the first page of its content, you could proactively, with the request of the first page, you could already trigger or serve the content of the second page, and therefore make every click really seamless without loading times, which could be a huge benefit. As well as not only think about table pagination, also about views. So for example, if you have a main view and some detailed view, you could analyze what typically comes next. What would be the next click or the next interaction the user performs, the next view to load, and this could already be pushed to the server, which would be quite some cool thing. And all this can be possible because the server can know better. And with that, thank you for the audience. And also I put up here the GitHub project where you can find this. It's not I made it really generic, so the UI5 use case of course works. But you are also able to serve different kinds of resources, also other projects, so it's really implemented in a generic way. Okay, thank you.
Thank you, Tobias, and also in time, so that we have time for one, maybe two short questions. Who wants to catch? So, just speak into the...
Oh, I just have to... Oh,
yeah.
Nice. Okay. As a software provider, how can I build my web content to benefit from these features? Meaning, right now what you explain, it's fully based on the server behavior. But if I deliver web content, let's say SAP UI5, what kind of information can I put inside SAP UI5 to make sure that the content is delivered intelligently?
You could actually, what could be an integration, because the UI5 tooling is pretty open. So this could maybe be integrated as part of this, such that you deploy your app and serve it with the UI5 tooling, and then maybe make use of this technology in order to get the server side also a bit faster.
Okay, another question, the last one? Yeah, in the back. Please, if you could do me a favor, and or I tried from here, but I can't promise. Okay. Okay. No, almost 2 lines.
Oh,
2 lines short.
Almost coming out
Yeah.
of this thing. Is this or will this be a thing for the frontend server or the gateway yet?
So there's still a proof of concept. Of course, there needs to be maybe further discussions. Maybe with this, I make people think about the server side as well. So there's no currently no development going on. This is really just a POC. But of course, if people would get interested and would put some implementation into their server, why not? So I cannot, from this, I cannot answer because it's really just a POC for now.
Any plans to share publicly because that is internal?
Of course, yes. I need to make this public as well.
The question was if you have plans to share it publicly. Yeah. Okay.
Yes, should be possible.
Okay, thanks, Tobias.